Hello, everyone. Welcome to the Department of Mechanical and Engineering, Mechanical and Aerospace Engineering session. My name is Vibu. I'm joined today by Dr. Edward Shear. He is a professor instructor at Carleton for our Mechanical and Aerospace departments. But before I pass it to him, I would like to just take a moment and say that Carleton acknowledges that the location of its campus is on the traditional unceded territories of the Algonquin Nation. In doing so, Carleton acknowledges it has a responsibility to the Algonquin people and a responsibility to adhere to Algonquin cultural protocols. So now I would also like to mention that if you have any questions during the presentation, please post them into the chat. I'll be there answering any questions you have. Now over to you, Dr. Shear.
Hi, everyone. Glad you could make it today. I'm happy to be here, take a bit of your time to present a bit about our department and a few programs we offer in our department. So I am in the Department of Mechanical and Aerospace Engineering, one of our several departments at Carleton, and we're going to talk a bit more about those today, and specifically some of the programs that we offer and some information about those programs so you can get a bit more. I know it's a difficult time of year, stressful probably trying to pick where you're going to go next year. So there's lots of things to consider. So I'm going to try and give you some information that'll help you make those decisions. So first of all, a little bit about me. I have a degree in mechanical engineering from the University of Waterloo, is where I did my undergrad, and then I did my PhD as well there. So I was at Waterloo for a total of 10 years, and my research and my background is all in mechanics modeling and a lot of work in the automotive sector. And then I moved to the University of New Brunswick, where I was a researcher and director at the Marine Additive Manufacturing Center of Excellence. So there I did research in 3D printing of metals, specifically for the marine and aerospace industries, which was very interesting and tons of fun. I learned lots. And then finally, I just joined Carleton recently at the beginning of this year as a new faculty member. So I'm also kind of new to Carleton. I'm learning the ropes and learning my way here. But I've loved it every minute so far, and I love being on campus. I love the city of Ottawa, and I hope that I get to see some of you guys next fall when you guys begin your university journeys. So let's begin. First of all, I think a good question that I like to ask students is, what actually is engineering? And I created a poll here. Let's see if it works. So yeah, if you go into the polls, here. So what is engineering? Is engineering designing things? Is it building things? Is it managing things, calculating things, working on a team, or is it all of the above? And then maybe some more. Yeah, so everyone's got votes in all the above, some designing things. So it's pretty good. Everyone's pretty much on the mark there. So engineering is all of these things. So let's go just to be a little bit more specific. If you were in the session previous to this, you would have heard that engineering is a protected term in Canada. So what that means is you cannot call yourself an engineer unless you are licensed in Canada. And to get a license, there's a few steps you need to take. The first one is what you guys will be starting next fall, which would be entering a accredited engineering program. It doesn't have to be in Canada, but Canada offers several schools with accredited engineering programs. Carleton University is one of those schools. It has to be a minimum of 4-year program. And once you have that program, you have to submit 4 years of work experience. And because Carleton has a co-op program, we will actually allow one of those 4 years to be counted during your co-op experience because it happens after your second year. So work experience during co-op or during your degree as a co-op after your second year of your schooling in an engineering program can count towards that time requirement, that experience requirement to get your license. And then the last thing is you need to write a law and ethics exam once you have required all that experience. So once you are licensed, you become a professional engineer. And professional engineering, or engineering in general, is any act of planning, designing, composing, evaluating, advising, reporting, directing, supervising, or managing. And it requires the application of engineering principles. So that's the use of math and science to solve problems. And engineering always concerns safeguarding of life, health, property, economic interest, public welfare, or the environment. So you'll learn as an engineer that engineers, especially in Canada, hold the safety of the public as paramount. So in the Faculty of Engineering and Design at Carleton, we have over 140 different programs and streams, and we have 3 departments, and that's in engineering, and 3 schools in architecture and design. As of this year, we have over 7,250 students enrolled and $90 million in research funding, which is quite a bit. And we have over 200 industry collaborations. So there's no shortage of access to industry and job opportunities through Carleton once you're here. Click on my slide. All right, so the Faculty of Engineering and Design. So I said there's 4 departments. The 4 departments are Civil and Environmental Engineering. We have the Department of Electronics, Department of Mechanical and Aerospace Engineering, and Department of Systems and Computer Engineering. So today I'm going to talk about our department, which is Mechanical and Aerospace. So within Mechanical and Aerospace, we have 4 different programs. We have Mechanical Engineering, which I'll call MECH. We have Aerospace Engineering, which is our AERO team, our AERO people. We have Biomedical Engineering, which is subscript BIOM. And then we also have a newer program called Sustainable and Renewable Energy Engineering, or SREE. So I'm going to go through each of these programs and talk about, in aerospace specifically, there's a few different streams you can take because we branch out into quite some detail into some of these programs. So we'll start with mechanical. Mechanical engineering is more or less my background, and it involves pretty much anything that moves or converts energy. So all of these different disciplines that we're going to talk about, these programs, are underneath the umbrella of mechanical engineering. Mechanical engineers are sometimes referred to as like the jack of all trades engineering. So we have to be pretty much aware or a hand or some knowledge of many, many different topics. And then from there, we can specialize into many different things, whether that's biomedical or manufacturing or aerospace or fluid mechanics. These are all specializations of mechanical engineering. So mechanical engineering is a very versatile engineering program. So like I said, it is very versatile. So what are some of those careers that you can have in mechanical engineering? So my background in research was a lot in manufacturing and computer modeling. You could also go into robotics. You could do hydraulics or machinery. You can work in the automotive industry, aerospace, energy, transportation, materials, and there's just so many more. So I've just added some pictures here to kind of give an idea of what's going on. So if you wanted to do aerospace, you're probably concerned with the movement of fluids around bodies. So here on the bottom, we could see an aerospace type parallel application in the automotive industry where we're trying to find or measure the aerodynamic behavior of a vehicle. Maybe we want to reduce the fuel consumption while it's driving or increase its efficiency, or maybe we want to increase its performance. We want more downforce. So we have to control the airflow around that vehicle. We would use mechanical and fluid mechanics engineering to do that. Maybe we were harnessing energy from the wind. We would design more efficient blades that can capture that wind energy. Or if we want to work in aerospace and we have new rocket designs, there's really high temperatures, really high pressures, we need to come up with some new materials that are going to withstand all of these stresses, these loads, these extreme conditions. So we could go into materials and manufacturing engineering. So here we have sort of a section of a turbine blade. It could be in aerospace, it could be for propulsion, it could be in rocketry, or we could be in energy, where on the top left or top right-hand corner there, we have a turbine blade for a steam turbine generator. And then on top of all this, we also have to be very good at using computers. Almost everything is simulated now. So all of our courses have, or most of our courses have some component that's going to introduce you to computation. So we're not just going to solve things with pen and paper traditionally, which we need to know how to do that very well. We're also going to use computer tools to be able to solve these engineering problems. And the diagram that's shown here is a computer simulation of the fluid flow around these blades. That's how we capture energy, and we can actually predict very well with computer simulations things like stress or temperature when these parts eventually go into service. So aerospace engineering is our next program. It's the same length, it's 4 years, and it's actually a specialization in mechanical. And within that specialization of aerospace, we have 4 different streams. So Did anyone know that aerospace actually had 4 different streams? Yes, we had some to know. Okay, good. So that's good. So in aerospace, there's 4 different streams. We refer to them as A, B, C, D, just to keep it simple. But stream A refers to aerodynamics. And I'll go into more detail with each of these. Stream B is aerospace structures. C, aerospace electronics and systems, or we call avionics. And then stream D is our space systems and design. So let's talk a bit more about each of these. So when you come into engineering in general, your first year is going to be focused on something called core engineering. So you're going to be in classes that are with engineers and engineering students from many different disciplines. So you might not just be your core aerodynamics class and students that are in the same program as you, you're going to meet many other students. As you progress through the program, so year 2, 3, 4, that's when you start to specialize. So year 2, you would start to get to your maybe core discipline type courses. So if you're doing aerodynamics stream, you might have your fluid dynamics courses. Later on in 3rd year, you might have computational fluid dynamics courses. And then year 4, you might learn things about compressible flow or really specific courses to your field. So if you wanted to take aerodynamics, these are some things that might interest you. So for example, I have on the right here, one innovation that really improved the airline industry, commercial airline industry, was something called a winglet. And you'll see these on newer aircraft now. And what happens is the difference in pressure on the top and bottom of an aircraft wing, there has to be a different pressure. That's what creates lift in the aircraft. But one of the side effects of this lift is that we have something called a vortex that forms around these wingtips. And they can create some problems. They reduce our efficiency, so we have to burn more fuel, which isn't good. And it costs more. And then also the turbulence that's generated from these vortices can actually cause disturbances of other aircraft that are passing through that turbulent air. So one addition to these wings was to add something called a winglet. And these winglets are able to greatly reduce the vortices that form at the end of these wingtips and improve fuel efficiency of commercial aircraft. So this is an application that an aerodynamics engineer might be working on. And you would be tasked with coming up with some models or doing math and science and applying computer simulations to try and figure out how do we design our aircraft, how do we design our wing components or some component to be more aerodynamic, to flow easier through the air or to take advantage of some sort of fluid flow and convert it to something that's useful. So stream B is our aerospace structures group. This is involved with anything to do with strength of materials or strength of some component. So when you think of structures, an aircraft or any sort of vehicle has to be composed of something that's going to give it some sort of strength. As a vehicle travels, it's going to be experiencing loads and different conditions, and we need to design these to withstand these loads and to withstand them safely. So if you wanted to go into structures, you would be looking at designing components that are going to basically give our flight systems, our aircraft strength. So here's an example of some innovation design that you could be doing. You could be working on a new next generation wing spar. So these would be the rigid components that are inside the wing that we can't see. They're beneath the skin. And they're what give this wing incredible strength. And new technologies in manufacturing or new materials might give rise to new ways of designing these things down the road. And so you could be working on in the future designing new structures to actually support these wings on aircraft. Or perhaps you could be working on new propulsion systems. There's a lot of drive for new energy systems to be used, new types of fuels for the aerospace industry. And this will require rethinking how we think of our propulsion systems. And so the structures engineer is going to have to design these systems to withstand the loads and the conditions of these new propulsion systems. So I'll skip C for a second because it's the one that's a little bit different than the rest. So stream D is our spacecraft or space systems design stream. This stream is involved very much with things that are going to be going into outer space. And it's much more, well, it's not much more involved. It's the problem can be much more broad in that now you have to think of all kinds of things around an aircraft. You're thinking about aerodynamics and how to get there. You're thinking about once it's in space, what are the conditions it has to deal with. You're thinking about what's the lifetime of this thing in operation. Maybe orbital mechanics is something important. You were wondering, what kind of orbit do we want this in? How are we going to perform service on it? These questions are very difficult to solve. And space systems engineering is, I find, quite fascinating. And an interesting, more really recent actual innovation is the development of something called the James Webb Telescope. Has anyone ever heard of the James Webb Telescope? It's so it's a new telescope that's being launched, and a space systems engineer perhaps would definitely have been involved in this process, where we have something that needs to be very, very large in space, but it's very expensive to send something very large in space. So we have to find a way to make it fit into a small package of a rocket and fit within this payload capsule. And then once it gets into space, how is it going to unfold itself? How is it going to prevent itself from damage? How are we going to ensure that this is going to work once it gets up there? Because once it's there, we can't do anything anymore. It's on its own. So that would be a great application for a space systems design engineer. So last stream in aerospace is our avionics. And the reason this is a bit different is because avionics has everything to do with the electronics and controls of an aircraft. So you're not only going to be taking courses in mechanical and aerospace engineering, you're also going to be taking some courses from electrical engineering, electrical and computer engineering. So that's why you see this split up kind of in year two. Year two, you're going to be taking some courses from electrical, whereas the other three streams won't be taking electrical courses. So avionics would be maybe looking at new control systems. So fly-by-wire is fairly common now, which means that all of the mechanical and moving components in an aircraft are actually controlled using electronics and motors, servos, control systems. And you'd be using these new technologies, developing new technologies to find new, more efficient, maybe safer way to operate aircraft. So let's look at the industry by the numbers. I like to always consider this when I'm going into a new program, or you're spending a lot of time and money in your future. So you want to make sure that it's a good investment. So what is the aerospace industry in Canada? So right now, aerospace in Canada is ranked, Canada is ranked third in global civil aircraft production activity. And there's about 27.2 billion in that aerospace industry that's directly generated revenue, and about 87,000 jobs in this industry in Canada, contributing to the Canadian economy. It's also a growing industry. So between 2011 and 2016, it grew 20%. And the industry as a whole is divided up into two major components. So we have aerospace industry activity, and we have, which is maybe the manufacturing, where we're actually building aircraft or building components for aircraft. And we have maintenance, repair, and overhaul. So that would be, we have aircraft that exist and we want to do maintenance on them for a different application. We'll see some examples of that. Or maybe we want to improve the life or upgrade an aircraft so that it can extend its life. 80% of the products that are produced in Canada for aerospace are actually exported. So we are a huge producer for the global aerospace industry. And the amount that the industry invests in R&D in Canada annually is about 1.9 billion. So there's lots of opportunity and there's growth in the aerospace industry. Okay, so you've got your degree, you've picked your specialization in aerospace. Where do you want to go now? So what kind of jobs can you get? So I have some information here that shows some examples of types of jobs you can get as an aerospace engineer, and some examples of some companies. So here's 5. It says 10 largest aerospace companies, but here's 5 of the 10 largest aerospace companies. The other 5 actually also operate in Canada and are listed below. So we have many companies operating globally and many in Canada itself that are working in the aerospace industry and use engineers in their work. So you could work in satellite and space robotic design. You could work in new aircraft design. A new aircraft design, I think, is this interesting blended wing body design by Airbus. You can work in rotorcraft design, developing new helicopters or things like that. Aerospace systems engineer, you could develop new things like landing gear systems, propulsions engineer, maintenance, repair, and overhaul. So I like this example of the water bomber aircraft. These are good examples of aircraft that have some base design, and sometimes these aircraft are retrofitted for different kinds of applications, such as being used as a water bomber. Or another growing field is in simulation design. So we don't want to have testing or the first time a pilot steps into an aircraft be still learning. We want to make sure they have lots of training and practice in something that's simulating as realistic as possible before they get into this aircraft. So simulation design engineers will take all of this knowledge and they would create essentially a video game that would be used for training pilots before they get into the real aircraft. So it's a much safer environment, and you can test things that would be much more dangerous to be tested in a real aircraft. So another component, another type of program that we have in mechanical and aerospace is biomedical and mechanical engineering. So those are BIOM program. There's a huge increasing demand for engineering and engineering applications in life sciences, and that's being able to either improve public health, improve medicine, improve the equipment that we have access to in medicine. It could also be something where we want to improve athletic performance. So I like a good example from Nike developing the new running shoe to try and break that 2-hour barrier for the marathon. That would involve some biomedical engineering applications and understanding how people run and how we can engineer people to run faster by giving them better equipment. So if you wanted to work in biomedical engineering, you could work in equipment design, you could work in human-machine interface. So that would be something maybe developing smart technology or wearable tech that's going to help with your health, or maybe it's something that could be helping medical professionals, doctors do surgeries or meet with patients or have things be remote or more virtual, or training systems. You could work in advanced manufacturing and developing new prosthetics or design implants. So 3D printing has a huge growth in this space here, where we're developing new materials and new printing methods so that we can have custom manufactured prosthetics and implants. And then probably the one that is marketed a lot and gets lots of attention is the athletic research and development. So that was that Nike example. So sustainable and renewable engineering is the last program that we offer in our department. And this is part of a push, I think, globally to find new sources of energy. So we cannot keep burning fossil fuels, and we cannot keep business as usual. We have to find new ways if we were going to be living in a sustainable way. So this program will introduce you to the tools and the science and math that you need to be able to solve these problems. And we have 2 streams offered in this program. So one of them is smart technologies for power generation. So that'll be something like if you've ever heard of smart grid. And we also have efficient energy generation and conversion. So if you wanted to work in sustainable and renewable engineering, maybe you would be working on designing the power plant of the future. You could be working on developing new types of energy sources, maybe new sustainable, friendly or eco-friendly fuels. You could work alongside construction industry in developing passive design or green construction materials, green construction methods. Maybe you're working in hybrid and electric vehicle design or new energy methods, new power units for vehicles. I like watching Formula One, and they're doing tons of innovation in improving the efficiency of their vehicles and moving away from fossil fuel but maintaining the power that they need for their racing. You could also go into working in sustainability policy. So in our department, once you're here, you probably want to know who we are. So we're called the Department of Mechanical and Aerospace Engineering. I am located in a building called the Mackenzie Building, and just down the hall is our main office. We're a single integrated department, so we're not 2 separate parts. Many other schools have their departments separated, and they're somewhat siloed. So mechanical might be different than aerospace, which might be different than mechatronics, which might be different than electrical. We're mechanical and aerospace, all these programs are all within the same department. So we work very well together, and we're very integrated, which is a huge benefit. In our department alone, we have nearly 1,300 undergraduate students. And I think first-year admissions are around 350 maybe a little over 350 this year. Within our department, our distribution is around 40% of our students are in aerospace, 20% in biomedical, 30% in mechanical, and then 10% in sustainable and renewables. Our entrance average is probably interesting to most of you. In aerospace is a bit higher, so 83 to 85%, mechanical 76 to 78%. And then within our faculty, we have 44 full-time faculty, and that's growing. We have 25 adjunct professors and 6 emeritus professors. So what is our undergraduate teaching and learning philosophy? This is something that I think maybe doesn't get considered too much when you're looking into an engineering school, but it is really important. And once you're there, sometimes I think you wish you paid a little bit more attention. So in engineering, our teaching and learning philosophy, like most engineering programs, is to be an engineer and do engineering, you need to have a sound foundation in math and science. And once you have that, and you can apply these principles and do design or solve problems, create machines, apparatus, processes, things that are going to benefit society. So you're not going to do this all alone. Theories and concepts can't be taught in class. We're going to be there to help you with the class component, but learning also requires some hands-on application of these theories. So you actually have to do stuff. And Carleton emphasizes a practical application of knowledge through experiential learning. So part of that is our co-op program, which you would have heard about if you attended the previous session. But our co-op program at Carleton is quite good, and you have the opportunity to gain experiential learning and work experience before you graduate, which is a huge bonus when you're joining the job market. We have a 1-to-1 ratio of lecture and lab problem analysis. So you're going to be sitting in lectures with someone like me, and then you're going to be spending the same amount of time in labs, or what we call problem analysis sessions, where you actually get to practice solving problems. You can do labs, you can do workshop training, and things like that with teaching assistants and other students and student peers that are going to help you with the material. There's a 3rd-year course that's devoted only to hands-on lab experiments and design project. So we have a full design course in your 3rd year to give you an introduction to what is engineering design and how do you conduct engineering design. And that course is entirely hands-on, which will give you some practical application that will really help when you get out into the real world. And then we also have a program-specific design course project in 3rd year. So in aerospace, we have an aerospace design and practice. That's one of the courses that I teach in 3rd year. And then when you get to 4th year, you'll be part of a large team-based design project. And there's many different design projects. I'll get into a few of them in the next few slides. But within that team, like you would be with an engineering team in the workplace, you're going to be working with many different people with many different roles. So this is going to give you a hands-on experience of what that would be like. And you would have lead engineers, which would be 3 faculty team members that are going to help lead you through this design project, and it'll be an 8-month project. So we call these our capstone design projects. So our 4th year design project is an integral and important part of our program. And it has over 25, I think 30-year history now of evaluating 4th year capstone projects at Carleton. And it was the first university in Canada to actually adopt a team-style capstone project. So it's a chance to apply everything you've learned up until that point. You can work in large teams, so you have to practice being better at teamwork and project management. It's student-driven, so we're there to help you and guide you, but this project is completely driven by you, and you guys are the leaders. And it's usually linked to some sort of industry, and we invite industry in to come and evaluate your design milestones. And it's much more than just writing equations in the classroom. You actually now have to apply these equations in a real application. And sometimes I like in these projects, the first time students are trying to apply these theories in the real world, they realize how many unknowns there are and how difficult it can be sometimes to solve these problems. So that realization is quite interesting to work through. And then they always involve some form of designing, prototyping and building of your actual designs. And then we get to the testing and showcasing phase as well. So here are just some capstone design projects that I wanted to share. These are also available on our website. You can look at with a bit more detail. We have a robotics design team that we're actually developing a robotic hand. There's video feedback, an integrated concussion assessment system, These are both biomedical applications. We have a net zero energy tiny house. So this tiny house operates completely off the grid, and it is net zero, which is very interesting. And this was completely built by students. And if you visit our campus, actually, you can see it. It's just outside my window. In mechanical and aerospace, three interesting projects that I think are, well, three that I'm aware of and involved with is the Carleton University Simulator Project. So this was completely developed by students. In this simulation, this orb that you see, you sit inside, and it is a virtual reality simulator for an aircraft. And not only is it giving you the visuals, but it's also moving around you in three-dimensional space. So the sensation you feel feels like an aircraft when you're flying. The project that I'm a team lead on is the fixed wing UAV. So this team is actually designing their own, and we're going to 3D print and manufacture a autonomous fixed wing UAV with a blended wing body design. So that's where the wing and the fuselage kind of blend together, and there's no clear separation between the two. And then another interesting team is the LTE controlled drone. So this would be maybe Avionics, where they're using different communication technologies to control aircraft. So beyond the classroom and beyond these engineering projects that are required as part of your program, there's also many other opportunities that are optional, but they're there to help enrich your program. And they're in engineering or they're outside of engineering. So clubs and societies are a huge part of Carleton, and there's more than 250 of these clubs and societies that you can be a part of. And they're 100% run by students and run for students. And I think a common one that many schools might hear of is the Formula SAE engineering teams. I think most schools in Canada have a Formula SAE team where students completely design, build, and race a race car, which is pretty fun. So that's my quick presentation. I hope you enjoyed it and got some more information about the program. I'm going to stick around and answer some questions, but I really look forward to hopefully seeing you again soon on campus next fall. So thank you for coming. Sure, should I tackle some of these questions in the chat?
Yeah, we could just talk about the questions in the Q&A, yeah, because we can't really type into those chats, so yeah, we can just speak about it.
I'm not sure what the attrition rate is after first year. I think it's kind of difficult to measure because sometimes the students maybe won't be successful in all their courses. They would have to retake a course, and they would be separate from students that might just completely change programs. So you could enter first year engineering in one program and then switch to a different program. But I'm not actually sure what the numbers are in there. I'm still in my first year here, and my experience in general is for first year engineering, I think about 80 to 85% of the students will continue on in some form in engineering. I don't know if that number is correct. I think that's close.
So the next question about what grades should I have to be accepted for the program? Typically, we look for students to have an average of around 85 or above. Aerospace is one of our most competitive programs, so to really stand out, we encourage students to have 85 plus average. Which stream of engineering would be most beneficial for a career in F1 or other racing series? I believe mechanical will probably be the best bet for you there. For which specific stream? Do you have any input, Professor?
Yeah, it depends on what you want to do in F1. So F1's very involved. They take all kinds. If you, what I think F1 looks for a lot is someone who is very innovative. So you can take any of those streams, but if you want to work in aerodynamics and you want to work with designing the form of the car to help control the wind, then I would say definitely the aerodynamics stream. If you want to design the actual mechanical systems, or maybe you want to work with Pirelli and design their tire systems, I would mechanical and materials engineering. If you want to design the control systems, how the driver interacts with the vehicle, that would be maybe closer to avionics and robotics type systems. So it really depends kind of where you want to go in F1. So definitely engineering and definitely mechanical and aerospace can definitely be a huge advantage if you want to go into that field. What percentage of aerospace jobs do you think you can get with a mechanical engineering job? And how much more flexible is mechanical engineering? So in mechanical engineering, it doesn't mean you can't specialize or take technical elective courses that have, let's say, an aerospace flavor. And maybe the job you have down the road is related to aerospace and that can help you get in the industry. But as an actual percentage of aerospace jobs you can get, I don't really know the answer to that because a lot of aerospace applications do have some pure mechanical engineering components. So they're not completely separate. Which stream of engineering would be most beneficial for a career in F1? Okay, we answered that. How many students do Carleton accept under avionics? I'm not sure of the actual program or stream specific breakdown. I just know that within the AERO program, so of the 4 streams total, I think we had 370 first year students come into the program this year.
We actually have a nice question in the chat. I think you'd be good to answer it. A student asked, I was given advice to take a mechanical engineering program plus a master's in aerospace engineering versus a bachelor in aerospace engineering to keep my options open after graduation. Since there aren't many jobs in Canada in aerospace, would you disagree?
I'm not sure. I know some schools, they offer a mechanical engineering undergraduate degree and then they don't have an aerospace undergraduate program. And then you can have a master's in aerospace afterwards. That would require you to do 2 more years of school before you could get into your field of work. Carleton's kind of unique in that we have a dedicated aerospace engineering undergraduate program. And we have a lot of industry that looks directly at our program to recruit because they know we're special in that having that unique program. So it's up to you. If you want to do a master's program after, you're interested in research and you want to do more, then the master's program and that path is definitely a good option. It's not a bad option at all. If you're not so much interested in staying in school for too long and you want to do your engineering degree and then get out in the world and do some engineering, some hands-on stuff, then maybe picking an engineering program that you can do as an undergraduate program in aerospace would be more beneficial for you. What are some examples of companies that hire co-ops for Stream D students? Stream D was, I forget. I mean, I'm still learning what these streams are. Stream D, I believe, was space systems. So NASA is a company, an organization I know would be working with these type of groups, or the European Space Agency. I'm also aware of hiring space systems engineers. There's also a satellite company that's actually based here well, they have an office here in Ottawa and in Mississauga called MDA. And they have some contracts with the Canadian government and the European Space Agency designing satellites that are used for agriculture, for example, or even NASA uses those satellites. So these are all examples of some companies and organizations you could work for. Are there many aerospace jobs in Western Canada? I know of some. Maybe if I can go back a few slides. How do I do that? There is, so on the picture of the companies. So there are some companies here. So Collins Aerospace, I think, is based out of Winnipeg. Viking Aerospace is in Alberta. I think KF Aerospace, one of these other ones, is also in Alberta. And then there's CMC Electronics and CAE are in Montreal. MDA's in Ontario and Montreal. Bombardier's in Quebec. And then Boeing and Airbus have, these are just some of the big ones. There's many more. But yeah, there are companies in both East and Western Canada. Is the aerospace engineering program in English? Yes, at Carleton, all of your courses will be delivered in English. But that being said, Carleton and U of O, University of Ottawa, do have a lot of cross collaboration. So in your engineering degree, I believe there are ways that you can take courses at University of Ottawa, and they do offer courses in French as well. So if there's some courses you're interested in maybe taking in French, that's not something that's impossible to do, even if you're enrolled at Carleton, because we work very closely with the University of Ottawa. Can we get co-op placements at NASA, CSA, while at Carleton? Yeah, you can, if you meet the requirements. So depending on where you want to work at NASA. So for example, if you want to work at NASA Ames in California, that's one of their propulsion labs. Some of those labs require you to be a US citizen, but not all of them do. So that would be sort of case by case specific, but it's definitely possible to have a co-op position with these organizations. Can we get co-op placements? Is it competitive to choose a stream in second year, or can we choose our first choice? I believe you have to choose your stream in first year, but
yes. So when you apply to Carleton, you actually do select which specific stream you want to go into, but you don't finalize your stream until second year, where you actually get to finalize and choose your stream of choice. But if you do want to switch, there is some drawback. Sometimes there isn't space in order to switch streams, so typically students aren't able to sometimes. But yeah, you do select your stream before entering into first year.
Mm-hmm.
The next question: are there co-op placements in Formula One? To be honest, I'm not sure about that. I think that depends on if Formula One itself as a company has placements available for students.
Yeah. So how Carleton's co-op works is we give you the framework within your degree to fit in co-op placements, and you go out and find these co-op placements in whatever field you want. So we're not going to control where you can look. You can, if you want to look in Europe, I know Glassdoor is a good resource. There's lots of good platforms that have job boards and job postings that you can go out and find your own maybe co-op engineering or junior engineering type positions. And I know Formula One, the team specifically, do hire co-op positions. I'm not sure about Carleton students going to those positions, but I do creep their job boards, and I do see postings from these Formula One companies looking for junior engineers or co-op engineers in their companies. Can you get co-op placements in Western Canada? Yep, you can get co-op placements anywhere in the world. And how do the program and facilities compare to the U of Ottawa program and facilities? So I'm not sure how Carleton. I'm not too familiar with University of Ottawa's facilities and programs. Although when I was in university, I swam, so I know University of Ottawa's pool because I swam there. But other than that, I don't know too much about U of O's engineering program and how it compares to us. I do know that there's a lot of collaboration between the two. So we are not two separate competing engineering programs. We work together very well. And just because you go to one or the other doesn't mean you're not going to somehow be, you could still somehow be involved with the other school. So there's some rivalry, of course, like there is with anything, and especially in our athletics teams, but in engineering, we work very closely together. I'm just trying to skip back and forth between the chat and the Q&A, but would it be possible to work at SpaceX? I have a friend of mine and a former student that does work at SpaceX, and in his position, he has a dual citizenship in the US, so he's able to work there. Some of their positions, I believe you have to be a US citizen. So that would be dependent of where you got your schooling. What percentage of students who graduate from the aerospace program find work in aerospace after graduation? That's a good question, and I don't actually know the answer to that. But I think that's something that if you would talk to, what would it be, the first year outreach, or Hannah might be a good person to ask that. I think she has maybe some numbers with that. A lot of it would be looking into alumni relations, but I don't know off the top of my head.
All right, so we actually have to wrap up this session. If students can answer their questions in the booths, those are available. We have professors and students available there to also answer any questions that you may have. There is a recording for this session that will be available afterwards as well. So if you want to revisit and see what the descriptions that the professor had to offer, that we can go over it again as well. But thank you for joining us. See you again in the next sessions.
Thank you, everyone.